Good evening, dear students. As in the previous class, we have discussed various physical quantities and system of unit for measurement of the physical quantities. Today, we will focus over the definition of SI unit of various fundamental physical quantity. As we know that fundamental physical quantities are unique physical quantities. So their unit must be unique and must not be based on any other physical quantities. So here, seven fundamental quantities are there. So we will define the SI unit for each of the fundamental quantities. And here, first of all, length is the fundamental quantities. And its SI unit is meter. So our motive is to define meter. What do you mean by meter? So we know that meter is the SI unit of length, and 1 meter of length is defined as the length of the path traveled by the light in vacuum during a time interval of 1 over 299,792,458 of a second. Here 299,792,458 is the actual speed of light in vacuum. And this definition was first of gave in 1983. And now another fundamental physical quantity is mass, and its SI unit is kilogram. So here we have to define kilogram. What do you mean by kilogram? The kilogram is defined as the mass of international prototype of kilogram, that is a platinum iridium alloy cylinder, which is kept at International Bureau of Weights and Measure at Sèvres near Paris in France, and this definition was given in 1889. Now third one is the fundamental quantity time, and SI unit of time is second. So second is defined as the duration of 9192631700 periods of the radiation corresponding to the transition between the two hyperfine levels of ground state of cesium 133 atom, and this definition was given in 1967. Now question arises here, periods of radiation corresponding to the transition between the, you would have studied about the hydrogen atom and a spectrum of hydrogen atoms, and in that spectrum there is a hyperfine lines. So transition between two hyperfine lines corresponds to a certain frequency and show period. Actually, fine line or in hydrogen spectrum, whatsoever is line there is basically energy level for various states of the electron that it can be there in that state. Fourth physical quantity, fundamental quantity, is electric current, and it has SI unit ampere. And so 1 ampere of electric current is defined as that much constant current which, if maintained in a two straight and parallel conductors, of infinite length and of negligible circular arc, circular cross-sectional areas, and is placed 1 meter apart from each other in vacuum, then it would produce between this conductor a force equal to 2 into 10 to the power minus 7 Newton per unit length of the conductor. Then such amount of current is called 1 ampere. And this definition was given in 1948. And fifth physical quantity, fundamental physical quantity is Kelvin. Temperature. And its SI unit is Kelvin. So Kelvin is defined as the fraction of 1 upon 273.16 of the thermodynamic temperature of the triple point of water. You know well that triple point of water is defined as the temperature at which water can exist in all the three states, solid, liquid and gas. That temperature is called triple points. So if we take 1 upon 273.16 of temperature of the triple point of water, then it is equivalent to 1 Kelvin. And this definition was given in 1967. Now, 6 fundamental physical quantities is luminous intensity, or simply intensity of light, and its SI unit is candela. So let us check out what do you mean by candela. The candela is the SI unit of luminous intensity in a particular given direction of a source that emits monochromatic radiation of frequency 540 into 10 to the power 12 hertz, or simply you can say 5.4 into 10 to the power 14 hertz, and that has a radiant intensity in the direction of 1/683 watt per solid angle, that is per steradian. And this definition was given in 1979. Now, last fundamental physical quantity is amount of substance, and its SI unit is mole. So let us define what do you mean by 1 mole. So mole is the amount of substance, and 1 mole means is the, so let us check out first. 1 mole means the amount of substance of a system which contains as many elementary entities as there are atoms present in 0.012 kilograms of carbon 12. And this definition was given in 1971. It means that if you take any sample of a substance of any metals or elements, and elementary entities are like molecules, atoms, electrons, protons, etc. It can be taken as. So if you take atom as elementary entities, then in a particular amount of substance, there will be as number of atoms as contained in 12 gram of carbon 12 atoms, then that amount of substance is said to be 1 mole. It means that in 12 gram of carbon atoms, we'll have as many carbon atoms as contained in given amount of substance, then that substance is said to be of 1 mole. Next, apart from these 7 fundamental units, we have 2 more physical quantities called supplementary physical quantities, namely plane angle and solid angle. So plane angle has SI unit as radian, and plane angle is defined as the angle which is equivalent to the ratio of arc, say ds, to the radius r. So if ds is the arc, differential arc, and r is the radius, then this arc sustain an angle d theta, differential angle d theta at the center. Then ratio of arc to radius is equal to angle d theta expressed in radian. So here d theta equal to ds upon r, and if ds equal to 1 meter and r is also equal to 1 meter, then it is said to be 1 radian. It means 1 radian of plane angle is defined as the angle subtended at the center of a circle of an arc of 1 meter and corresponding radius of 1 meter, then this angle is said to be of 1 radian. Now next one is solid angle, and solid angle is another supplementary physical quantity, and it is 3-dimensional, related to 3-dimensional, just like conical shaped object. So solid angle is denoted by omega and is defined as the ratio of the intercepted area dA of a spherical surface described at the apex O, which is situated at the center of the sphere, to the square of radius. So d omega is just equal to elementary area divided by a square of radius. So it is just equal to ratio of elementary area over a square of radius. And this is called steradian. So SI unit of solid angle is steradian. Now something important to be noted down: conventions that are adopted while writing a unit. We must keep in mind, because you would not be ample time to study all these things again and again, even in higher classes, and therefore you must carefully learn it all, and so that you can implement it in higher classes and everywhere. So conventions that are adopted while writing a unit. First of all, number 1, even if a unit is named after a person, you can say that it is a name of a scientist, just like a Newton. The unit is not written in capital letters. That is, we write joule not starting with capital G. But when this unit is abbreviated, written in short form, then we must write the symbol with capital letters. So here, if you write joule in full form, then you must start with a small letter J. But if you write it in a short form, just J, then you must write it in capital. Now, second one is for a unit named after a person, the symbol is capital letter. That I have already discussed. For joule, we write capital J. Although in order to write joule in full form, we must start with a small j, but in symbol, we must write capital because it is a name after a person. And the rest of them are in lowercase letters. If units are not after name of a person, then it can be symbolically, even it can be represented symbolically by small letters, not capital letters, because it is not named after a person. So it must be written in lowercase. Like second is a unit of time, and it must be symbolically written as, with a small s, not capital S, because second is not a name of a scientist or a person. Now, third one is the symbol of unit do not have a plural form. Just like you write meters, 5 meters, 10 meters, 100 years, this could be wrong. You must not make it plural. Unit must not be expressed in plural. So, as for example, 70 meter, it is correct. But someone say that 70 meters, this would be wrong. So, symbol of unit must not be expressed in plurals. But full forms of unit may be expressed as plurals like meters. Here 10 Newton, it is correct, but 10 Newtons, in order to make it plural, you just attach S, this could be wrong. Next one is punctuation marks are not written after the unit. As for example, 1 liter equal to 1000 cc, it must not be written as C.C because it is unit. It is not the abbreviation of anything. So we must follow all these 4 instructions which is important while writing unit. Now, some units are retained for general use, though outside the SI units, although these are not SI units of physical quantity. Still, these units are retained for general use in day-to-day life. Like, these are the units: minute, hour, day, year. All these 4 units are units of time. And we use all these 4 units as per our convenience. And degree is unit of angle, liter, unit of volume, ton, unit of mass, carat, you can say that unit of mass, and bar, unit of pressure, and curie, unit of radioactive decay constant. And similarly, Roentgen, this is basically unit of a specific charge, quintal, unit of mass, and band, unit of area, and air, it is also unit of area, and hectare, unit of area, and a standard atmosphere, it is unit of pressure. So all these are not SI unit of physical quantity, but these units are used in day-to-day life. That's why it is written for general use. And and now you have to keep in mind all these symbols, all these units and symbols of the corresponding units given here. Minute is abbreviated as MIN, and hour is abbreviated as H, and day is abbreviated as D, and year is abbreviated as Y, and degree is abbreviated as 0, and liter as L, and ton as small t, and carat as a small c, and bar as bar, and curie as ci, and Roentgen as r, and quintal as q, and barn as b, and air as a, and hectare as ha, and atmospheric pressure as atm. And full form, you know, value of SI, value in SI unit of these units: 60 seconds equal to minutes, 60 minutes equal to hours, and 24 hours or 86,400 seconds equal to hour a day, and 36 365.25 day equal to 3.156 into 10 to the power 7 seconds. So 1 year in the order of 10 can be expressed at 10 to the power 7 seconds. So if someone lives 70 years, his or her life can be expressed in second as 70 into 10 to the power 7 second. And degree, you know, will that 1 degree here, by mistake it has been written as 10, but it must not be 10. This degree symbol must be over 1 in place of power, exponential form में. And 1 degree equal to pi by 18, 180 radian. So you can say that 180 degree equal to pi radian, therefore 1 degree equal to pi over 180 radian. Similarly, liter, 1 liter equal to 1 cubic decimeter and equal to 10 to the power minus 3 cubic meter. And 1 ton equal to 1000 kg, 10 to the power 3 kg. And 1 carat equal to 200 milligram, or you can say that 20 gram, because 1 milligram, 1 centigram equal to 10 milligram. So here 200 milligrams there. So even you can express it in gram. And 1 bar equal to 0.1 MPa. M stands for here mega. So 0.1 megapascal, or even you can say that 10 to the power 5 pascals. And Curie is expressed as 3.7 into 10 to the power 10 second inverse. And so on. So now come to the point. Now measurement of length is to be discussed. So far we have discussed about various physical quantities and their fundamental units and definition of units and criteria for standard units. Now we are going to deal with the methodology of measurement of distance, that is length. Length is one of the physical quantity. So this can be done in two different ways, one for direct method, one for an indirect method. So for the two case or two region, we can use indirect method for measuring length. One is very large length can be measured in direct method, like distance between sun and earth. One cannot be able to measure it manually by taking a rope and tape, etc. So indirect method can be used to measure distance between galaxies, can be used to measure using indirect method, because it is not possible uh, to physically go from one galaxy to another galaxy. Now, so in case of macroscopic length, we use indirect method. Similarly, in case of microscopic length, again we use indirect method, because microscopic object we cannot be able to use manually, because it is not even visible to us. Like size of atom or molecules, one cannot be able to measure, because atom or molecule itself is not visible. How can one measure it? So we use indirect method. So we have learned that for measuring large distance or macroscopic length as well as microscopic length, we use indirect method for measurement. And finite length can be used to be measured using direct method. So here the order of distances vary from 10 to the power minus 14 meter, that is radius of nucleus, to 10 to the power 25 meter, that is radius of universe. So 10 to the power minus 14 meter can be taken as microscopic length, and 10 to the power 25 can be taken as microscopic. Order of distance varies from 10 to the power minus 14 meter, that is radius of nucleus, to 10 to the power 25 meter, that is radius of universe. So these are the range of length which could be measured by human being. So the smallest limitation of length is 10 to the power minus 14 meter, and largest limit is 10 to the power 25. So only this range of length can be measured either by direct or indirect method. So we as a human being have limitation to measure the smallest length, that is 10 to the power minus 14 meter. And beyond this, one cannot measure this with great accuracy. Similarly, we can measure radius or diameter of universe using indirect methods. So distance ranging from 10 to the power minus 5 meter to 10 to the power 2 meter, or you can say 10 to the power minus 5 meter to 10 to the power 2, means 100 meter, can be measured by direct method. This is the limitation of human eye and human capacity. He or she cannot measure a length smaller than 10 to the power minus 5 meter. And even he cannot be able to measure a length of 100 meter, greater than length of 100 meter with great accuracy. So it has a limitation that we can measure with the direct method, which involves, and direct method involves comparison of the distance or length to be measured with certain chosen standard length. So one cannot compare, because there will be an error. If you have length more than 100 meter, then how can you take a certain chosen standard of length of 100 meter? It will be inconvenience. And if you take a smaller standard of length and then you try to measure the length bigger than 100 meter, then there will be error. So there is a limitation to our perception that we can only measure a distance ranging from minus 5 meter, minus 10 to the power minus 5 meter to 10 to the power 2 meter. For example, a meter rod can be used as chosen standard to measure distance as small as 10 to the power minus 3 meter. So meter rod can be used to measure a distance of 1 meter or even 10 to the power minus 3 meter. So meter rod can be used to measure a length of 100 meter and length of 10 to the power minus 3 meters. So 10 to the power minus 3 meter is the smallest limit of meter rod, and bigger limit may be 100 meter or more than meter. Now, if one try to measure a length of a smaller than 10 to the power minus 3 meter, then we cannot use meter rod. Then we need another device to measure, and that device is a vernier calipers. It can measure a length even smaller than 10 to the power minus 3 meter. So it can measure a length up to a range of 10 to the power minus 4 meters. And if one try to measure a length even smaller than 10 to the power minus 4 meter, then he or she again need another measuring device called a screw gauge. A screw gauge is used to measure a distance or length as small as 10 to the power minus 5 meter. And if one try to measure a length even smaller than 10 to the power minus 5, then he or she need another mechanism or device. So for very small distance or very large distance, we use indirect method to measure. So let us check out indirect method for measurement. As for example, measurement of large distance. So there are following indirect method that can give you the rough measurement of large distance. So following indirect method may be used to measure a very large distance. First method is parallax method. In parallax method, the same object is being observed from two different places. And then angle between the line of sight from the two different places is gauged or can be measured, and using the concept of angle between the line of sight while observing the same object from the two different places is noted down, and then we apply a formula for arc and length, that is ratio of arc to length or arc to radius is just equal to angle in radian. So let us consider a far away planet which is appearing as a point P, and now assume that it is situated at a distance d from our two eyes. So distance between the two eyes can be taken as a parallax length. This is denoted as b small b, and this b can be treated as arc. Suppose that lines joining the planets to the left eye, say L, and keeping right eye closed, and then you observe the planet. Then your line of sight is this one, L to P. Now, closing the left eye and open the right eye. Then line of sight is this one. Planet is at their own position. Now, only difference is that when you observe the planet with the left eye and then with the right eye, then angle between the two line of sight is theta. So the angle theta is called parallax angle. That is angle between the line of sights when observed with the two eyes separately. So it is parallax angle or sometimes also called parallactic angle. And distance between the two eye is called basis. So we need a parallactic angle and basis to measure, which is in our range. We can measure. Although planet is not in our reach. We cannot go to planet and then to measure distance between planet and so. So we use the concept that what we have to measure, which is within our reach. So we can measure distance between our two eyes as a basis, and we can measure parallactic angle using a device, receptor. Orientation of receptor can help you to measure the angle. As the planet is far away, therefore, distance between the planet and eye is much more larger and greater in comparison to distance between the two eyes. Therefore, distance between the two eyes is here a straight line, but as this line is negligible in comparison to this distance, because planets are far away even in crore kilometers, but distance between the left and right eye is in centimeters. So in comparison to several crore kilometers, this length of centimeters between the two eyes can be neglected. And even then we can treat as this a straight line L to R as a curved line. We can treat as a arc. Then there will be no error because this length is so small, so we can treat it as an arc. And therefore theta is very small for this separation. Then taking the distance LR as circular arc of radius D and distance between eye and planet as radius, and then we have this relation. We know that when angle is measured in radian, it is mathematically expressed as a ratio of arc upon radius, arc over radius. So here radius is D and LR is the arc. So LR equal to B for basis and D for radius. So ratio of basis to radius equal to angle in radian. And angle can be measured from the surface of the earth. We have so many options to measure the angle, which is subtended at the planet itself. So angle is measured and basis can be measured, but D is not known and cannot be measured directly. So here D equal to basis divided by angle in radian, and whatever calculation do we get will be obtained in meter. As for example, in order to measure the size of sun or moon, diameter of sun or moon, is it possible that one can be standing at one edge of this sun and other could be standing at the other edge of the sun and then can measure? Not possible. Even in order to measure the diameter of moon, not possible. Then we can use parallax method to measure. As for example, we are sitting on the surface of the earth, standing on the surface of the earth, and then we look one of the edge of the moon with the help of line of sight, and then we try to look the other edge of the moon, opposite edge of the moon here, diametrically opposite, and then we measure the angle subtended by the two line of sight, and we can then apply taking this diameter as r, because this distance from moon and surface of the earth is very far away and can be measured in uh, almost 3 lakhs kilometers. On the other hand, this diameter is not in lakh, even not in thousand. So this can be treated as r. So now applying same formula, arc upon radius equal to angle. Angle is to be measured because it is in within our reach, and this distance is to be measured. This distance can also be measured using echo method. Then size can be obtained. This radius is known, angle is known, then this arc can be determined. So here we see angular size of planets, alpha, here is angle, and this is the ratio of diameter of the planet divided by distance between the planets and point of observation on the surface of the earth. So angle alpha can be measured from the same location on the earth, and it is the angle between the two directions when two diametrically opposite points of the planets are viewed through the telescope. So since D is known, the diameter D, since capital D is known, because capital D is the distance between the point of observation and one of the point on the surface of the planets, which lies at the end point of the diameter. So this capital D. So it is the angle between the two directions when two diametrically opposite points of the planets are viewed through the telescope. As D is known, already known, the diameter small d of the planet can be determined with the help of knowledge of capital D and angle. These two can be measured easily, and then size of planets can be known indirectly. Without going onto the planet, one can measure size of planets. So far we have learned this way. This was the parallax method. Parallax method can be used to measure very large distance, like astronomical distance can be measured using parallax method. Now, on the surface of the earth, one can use to measure, to locate the position of ship or jet in the sky. One cannot be able to measure directly. So echo method or reflection method can be used to measure the depth of ocean, can be used to measure the location of jet. So, and even can be used to locate the prey by the bats. So this is the echo method. This method is used to measure the distance of hill. A gun is fired towards the hill, and the time interval between the instant of firing the gun and instant of hearing the echo of the gunshot is noted down. So now we have time interval and a speed of the sound in that medium is known. So with the knowledge of time interval and a speed of sound, one can be able to measure distance of the hills from the observer without measuring directly. So it can be known indirect method. This is the time taken by the sound to travel from the observer to the hill and then back to the observer. So if we consider velocity, v is the velocity of sound and s is the distance of the hill from the observer, then sound go first traveling a distance s and then reflect back and come to the observer again. So total distance equal to s plus s equal to 2s, and time taken to go from observer to the hill and then again back to the observer is t. So we know total time taken, and then we apply the formula speed equal to distance upon time. So distance equal to 2s and time is known. So this 2s must be equal to speed into time. So v into t equal to 2 into s. Therefore s equal to v into t divided by 2. In this way we can measure indirectly the distance of the hill. Now, in place of sound wave, laser can be used to measure the distance of the moon from the earth. As you know, if you treat it as moon, then laser light can be used to measure this distance d, an angle this can be measured. In this way, we can measure this thing. So, similarly, in case of laser light, here, laser is a monochromatic light of single wavelength and is intense light and unidirectional beam of light. It travel in the space without deviation. It travel in a straight line. So if we take t is the time taken by the laser beam in going to and returning from the moon, this is the total time t, then distance can be calculated from the formula speed of laser light c into time t must be equal to total distance travel in going and then coming back. So in going it is s and again coming back is s. So s plus s 2s, and this must be equal to c into t. So 2s equal to c into t, therefore s equal to c into t divided by 2. C is already known because the speed of laser light or simply light is 3 into 10 to the power 8 meter per second. And time is to be noted down, and putting this value we can calculate. Now, so far we have learned about the method to measure very large distance in indirect method. Now, very small distance cannot be measured directly. Even here we can use indirect method, but method will be different from that of the measuring distance, very large distance. So here we use first method using electron microscope. Estimation of very small distance, electron microscopes can be used to measure. Or for visual light, the range of wavelength is from about 4,000 angstrom to 7,000 angstrom. You know well that 1 angstrom is another unit of length, very small unit of length, and it can measure length up to the atomic scale, and 1 angstrom equal to 10 to the power minus 10 meter. This is so small length. Hence, an optical microscope cannot resolve these particles with the size smaller than this. No, we know that light has wavelengths 400 angstrom, 4,000 angstrom, 7,000 angstrom. But particles smaller than 1 angstrom cannot be measured with the help of optical microscope. Therefore, we use electron microscope. So hence, an optical microscope cannot resolve particles with the size smaller than 10 to the power minus 10 meters. So electron beams can be focused by properly designed electric and magnetic fields, and the resolution of such electron microscope is limited And finally, by the fact that electron can also behave as a wave. So we can use electron as a wave or matter wave, and then we can resolve the image of microscopic object like atoms and nucleus. So wavelengths of an electron can be as small as a fraction of angstrom. So wavelength is even smaller than that of single angstrom. So such electron microscope with the resolution of 0.6 angstrom have been built by now, and they can almost resolve atoms and molecules in the materials. So internal structure of matters can be viewed with the help of electron microscopes. And in recent times, tunneling microscopy has been developed, in which again the limit of resolution is better than angstrom. So it is possible to estimate the size of a molecule. Another indirect method is Avogadro's method. Electron microscope can be used to measure a smaller distance, microscopic length, and even another method, Avogadro's method, it can be used to measure atomic or molecular size. A simple method for estimating the molecular size of oleic acid is given below here. Suppose we have oleic acid as a substance and we have to measure the size of molecules of oleic acid. As you know well that even molecule itself is not visible to our naked eye, so one cannot measure it. And molecules are so small that we cannot have any device to measure it. So indirect method can be used here. Oleic acid is a soapy liquid with large molecular size of order of 10 to the power minus 9 meter. Even you can say nanometer. So this idea is to first form a monomolecular layer of oleic acid on a water surface. First of all, we form a layer of oleic acid over the surface of water in such a way that in that layer, only one molecule can be fitted. It means you can say that thickness of layer will be, thickness of layer is assumed to be diameter of a molecule. It is so thicker. So we dissolve in the mechanism. What we do here, we dissolve first of all 1 ml of oleic acid, that is 1 cubic cm of oleic acid in alcohol to make a solution of 20 ml or 20 cubic centimeter concentration. And again, then we take 1 cubic cm of this solution and dilute it to 20 cubic cm, again using alcohol. And therefore, after that, now we have a concentration of solution is of 1 upon 20 into 20, that is 1 upon 400 cubic cm of oleic acid per cubic cm of solution. This is the concentration of the oleic acid solution. Now next, we slightly sprinkle some lycopodium powder on the surface of water in a large trough or tray, and we put 1 drop of this solution in the water. As you put a drop of solution, due to lycopodium powder, this drop spreads into a thin and very large and roughly a circular film of molecular thickness in water on water surface. So now we have thickness we assume the thickness as a molecule size, and area of the spread area is measured, and then we multiply the spread area and thickness of the film, so we get a volume of the film, and we have already concentration of solution known, and we measure the or assume the volume of one drop of solution, and we compare this volume with that area into thickness of the film. Then we quickly measure the diameter of the thin film, that is thickness of the film, to get its area. To get its area. To get its area A. Now suppose we have a drop. We have dropped n drops in the water, and we measure volume of one drop of solution, and then total volume equal to n into volume of single drops. And this n into volume of single drop can be equated with the area into thickness of the film. So initially we determine approximate value of each drop, say V cubic centimeter. V is the volume of one drop. So volume of n drops of the solution equal to n times the volume of single drop. Now amount of oleic acid in the solution is just equal to volume into concentration of the solution. So we here multiply the volume of oleic acid solution into concentration of the solution. So the solution of oleic acid spreads very fast on the surface of water and forms a very thin layer of thickness T. So this thickness, when multiplied with the area of the layer or thin layer of the oleic acid, then it gives volume. Area into thickness equal to volume. And this volume must be equal to this volume, because both the things represent same amount of volume. So here this spreads, then the thickness of the film can be obtained by equating this volume NV into 1 upon 20 into 20 cubic cm equal to A into T. So therefore T equal to NV divided by 20 into 20 into area of the film. Now area can be measured very easily, volume can be measured, and number of drops can be counted, and hence thickness of the film can be obtained. Now this thickness is nothing but what? Diameter of molecules of oleic acid, because we have already discussed that we take a monomolecular layer of oleic acid. That means in one layer is as much thick as diameter of molecules. This is called monomolecular layer. As you arrange the apples in a plane, then diameter of apple can be treated as the layer of monomolecular, and in that plane arrangement of apple can be treated as the thin film. So here now, so if we assume that the film has monomolecular thickness, then this becomes the size of diameter of the molecules of oleic acid, and the value of this thickness comes out to be the order of 10 to the power minus 9 meter, which is size of molecules of oleic acid. Now ranges of lengths that exist in the universe, the size of object we come across in the universe varies over a very wide range. This may vary from the size of order of 10 to the power minus 14 meter, that is size of nucleus of the atom, to the size of order of 10 to the power 26 meter, that is size of universe, which is observable. So we also use certain special length units for short and large length, which are given below. Uh, we can measure a length up to the 10 to the power minus 14 meter, but if less than that one, that length is called Fermi, and it is symbolically written as 1f, and 1 Fermi equal to 10 to the power minus 15 meter. Similarly, angstrom, it is symbolically denoted as, and 1 angstrom equal to 10 to the power minus 10 meter. And bigger unit is here, large unit, astronomical units. 1 astronomical unit, it is abbreviated symbolically as AU, A for astronomical, U for units, and is equal to 1.496 into 10 to the power 11 meter. It is basically average distance of the sun from the earth, because while earth revolving around the sun, the distance between sun and earth is not same, because path of revolution of the earth is not circular. That's why we take average distance between earth and sun, and that is called astronomical unit. Next one is light year, which is abbreviated as LY. It is also a bigger unit even than that of the astronomical unit, and 1 light year equal to 9.46 into 10 to the power 15 meter, and it is defined as the distance that light travels with a speed 3 into 10 to the 8 meter per second in 1 year. This is called 1 light year. And even bigger unit of length is parsec, which is bigger than that of light year, and it is equal to 3.08 into 10 to the power 16 meter, even bigger than this one. And 1 parsec equal to 3.26 light year. It is defined as the distance at which average radius of the Earth's orbit subtend an angle of 1 arc second. That is called parsec. So I think that today we will discuss another range of order of length, and this would be the last topic. Ratio of longest to shortest. Here we see size of proton is of order of 10 to the power minus 15 meter. Size of atomic nucleus 10 to the power minus 14, and size of hydrogen atom 10 to the power minus 10, and size of length of typical virus, so-called you say virus size of virus. Nowadays coronavirus is so dominant worldwide, and size of coronavirus is although bigger than this one, 10 to the power minus 8 meter. Size of coronavirus is of 10 to the power minus 5 meter. That's why it can be stopped by mask. But if it would have been size of this size 10 to the power minus 8 meter, then mask would not be able to stop it or check it. Now wavelengths of light 10 to the power minus 7 meter, and size of red blood corpuscle, red blood cell, you see, of 10 to the power minus 5 meter, and thickness of paper 10 to the power minus 4, and height of Mount Everest from the sea level is 10 to the power 4, and radius of earth is of order of 10 to the power 7, and distance of moon from the earth of 10 to the power 8, and distance of sun from the earth is of 10 to the power 11, and distance of Pluto from the sun is of 10 to the power 13, and size of our galaxy 10 to the power 21 meter, you know well, and distance of Andromeda A galaxy is of size of 10 to the power 22, and distance of boundary of observable universe, you can say diameter of universe, is 10 to the power 26. This is the limitation that we can observe the universe up to this range, not beyond that one. That's all for today. And next, in the next class, we will discuss about another fundamental physical quantity and its measurement, that is mass. So that's all for today. Thank you.